Hey guys, it's Solbyte, and today I'm going to be going over vectors. So what exactly is a vector? So you can think of a vector as something that's very similar to a dynamic array, in which it's basically an array that can dynamically change its size, except a vector has its own unique functions and methods used to access, insert, and erase the values inside of the vector. But basically, it represents an array that can change its size dynamically. So try to think of it like in that way. It's kind of like a better array, basically. So I'm going to go and show you guys kind of an example. So the first thing that we'll do is we will include vector. All right, so we need to include that from the standard template library. And we're going to go down here, and what we're going to do is we're going to create a vector of strings. So the way that we do this is we say vector, and then we use these brackets here, the same ones that we use up here for the, including our string, IOStream and vector. So we're going to use the brackets, and we're going to define the data type that we want to be stored in this vector. So for us, we're going to create a basketball team, and it's just going to be names for right now. So let's just do string. All right. And we'll go ahead and name it. We'll just name it team, and let's start filling it up. So we'll do the goat, then we'll do the other goat, Jordan, and then we'll do the other goat, rest in peace, Kobe. All right. So now we have a team, a vector that is storing 3 values that are strings. And yeah, so it's very similar to the syntax of an array where, like just for example, just to kind of have it side by side, we could do string team, and we can do equal to, the same thing, basically, just LeBron, Michael, and Kobe. And I'm going to show you guys kind of the differences as far as what a vector can do. But this is, as you can see, very similar to how we would create an array. The only main difference is how we define that we're creating a vector and how we define we're creating an array. But this is still the same. The way that we fill in the values when we define the array or the vector is still relatively the same. So anyways, now let's go into some of the cool and unique features of a vector. So as you guys know already, because I just told you, a vector is a dynamic array, so we can change its size. So we can change its size dynamically. So what I want to do is I want to kind of show you guys how this works. So first thing we're going to do is we're going to use team to to access our vector. And what we're going to do is we are going to check the size of team. And we're also going to check the capacity of team. Now, size and capacity are 2 entirely different things. This is very important. The size is how many values are currently in the vector. The capacity is how many values can be stored in the vector. So we're going to kind of see more of how this works here in just a second as I start adding more values to it. But for right now, let's go ahead and just kind of check the current size of this. So we'll do, go ahead and compile. Oh, wait, what did I do? Oh, right. Okay, yeah, sorry, I didn't, my bad. I didn't see out it. Okay, so sorry about that. I was just calling the size and the capacity return values without actually printing them, so my bad. But anyways, now let's do this. This should work. Oh, wait, that's not. There we go. All right, so we get 3 and we get 3. So basically the size right now is 3 values, so that adds up, and the capacity is 3 values. So that's how many, that's how much can be stored inside of the vector. Now, what happens if we add 1 to it? So these are dynamic, so that means that the size can change based on what we add or what we delete. So now I'm going to introduce the pushback. So the pushback, basically what this does is this is allowing us to add a value, add a new string to the very end of the array. That's basically all it does. It goes to the end of the array and just adds 1 to the very back of it. So what do we want to add? Let's add Luca, all right? So now let's kind of get the exact same thing. Let's just see what prints out now. See if it's any different. So 3, 3, that's from up here. All right, and then we get 4 because we added Luca, but then we get 6. The capacity increased more than it probably should have. In fact, it increased by doubling its normal capacity of 3. So why is that? So what happens is whenever something is added that exceeds the capacity, the vector automatically doubles the capacity that it can store inside of it. And this is very useful because that way, every time you add a new player or, a new value to a vector, it's not having to constantly increase the capacity because that would kind of run a lot slower. So what it does is instead, whenever it exceeds the capacity, it just doubles the capacity. That way it's a little bit more efficient, right? So, but now this is kind of an issue in terms of memory, right? Because what we don't want is we don't want a vector to have an incredibly large capacity, yet, we ended up deleting a lot of the values inside of it. So, like half of it isn't even being used. So what do we do about that? So to do that, first I'm going to just kind of I'm going to put Luca up here actually. And I'm going to add a few more, I think. We're going to add, let's add Kyrie. All right. And then let's add Trey. Okay. There we go. So we have six players up here. So what we're going to do now is we are going to use the method pop back. So pop back is, just like pushback, it goes to the very end of the vector and deletes the very last item. So that's really all it kind of does. We don't need to specify what we need to delete. We just, state that we want to do that. So now what we're going to do is we are just going to do that 3 times. All right, so we should only have 3 of these players by the end of this. Let's go ahead and run this first and see. So, okay. So here, obviously we start off with 6 and we have 6 in size and 6 in capacity. But then we delete 3 from the very back of the vector. And so we're left with a size of 3, but a capacity still for 6. Right? And sometimes this can be very troublesome, especially for a very large vector. I mean, it's going to take up a lot of memory, and we don't want that. We want to, write efficient programs. So what we can do is we can use a different method, right? I'm actually going to go and copy this. That way we can kind of see the before and after effects. We can use the method called shrink to fit. So what this is going to do, as it probably sounds, it's going to shrink the capacity to fit the size. And that's basically it. So we can use this whenever maybe we delete, a large amount of the values that were already in the vector, and we want to ensure that it's still efficient and not running too slowly, not taking up too much memory, etc. So let's go ahead and actually run this and see. So yeah, up here, this is just the normal, the normal size and the normal capacity. And then we delete 3 and the capacity stays at 6. But whenever we use shrink to fit, it goes back down to 3. So perfect. All right, so we went over how to add values to the end of the vector, right? And to delete values at the end of the vector, and how exactly the dynamic memory actually kind of works for these vectors. So now let's show a couple other really cool use cases. One thing is, what if you want to insert a value at a certain place in the vector, right? Maybe we don't always want to add, a value to the very end of it. Maybe we want to add it to the beginning or the second, index or, whatever. So how do we do that? Well, we can use the insert and the erase methods for the vector. So what we can do is we can do team insert. And what we need to do now is we need to put in 2 arguments for insert. We need to add where we want to insert and what value we want to actually insert. So how we're going to do this is we're just going to use team.begin, right? So we're going to insert at the very beginning of the vector. And what value do we want to add? Let's do Russell. All right. And now we'll just, we'll see out the very beginning of the vector, so that way we can kind of see for ourselves. So let's open up the terminal and run this. And there we go, we get Russell. So Russell was added to the very beginning of this vector. Okay. And now let's kind of do a little example with erasing. So let's do team erase, and it's very similar. We can just do team dot, begin. Maybe we want to get rid of Russell now. So let's go here and we'll do team dot begin. And I guess I'll do this again too. Yeah, probably smart. So now we're going to go down here and we will see that we get Russell for the first C out because Russell was added to the very beginning. But whenever Russell is deleted or, erased, then LeBron is the first in the vector. However, if you want to add something, let's say to the second index or the third, right? What we can do is we can just do +1, +2, +3, or, whatever you want to do. So let's do +1 and let's actually see if that works. So let's just do +1. We go down here and look at that. We get Russell and we get Michael. So Russell was now in the second index. After we deleted Russell from the second index, we get Michael. So very important as well. Doing this method is not going to delete what was there. It's just going to push it either back or, it's just going to push it somewhere else in the vector. It's not actually going to replace LeBron with Russell. It's instead going to move LeBron to, the second index and put Russell at the index that we specify. So, and now if we want to iterate over the vector, we can just do a nice simple for loop and kind of get all of the values. And we can use the size method, not the capacity method. Very important to use the size method and not the capacity. And we can go down here and let's just see out each player of the team. So let's go and do that and run this. As we can see, we get our entire 6-man lineup. Perfect. And there's a lot that we can do with vectors. There's a lot more that we can do with vectors. But just for the purpose of this video, I'm going to leave a link in the description for the different methods and just the different use cases that you can use a vector for. But, this kind of highlights the main functionality of a vector. It's just a dynamic array that has these really useful methods that we can use to access and add values to that array. So, and yeah, that's kind of about it. So, if you guys have any questions, let me know in the comments. I'm obviously going to leave some resources in the description, like I always do. And that's about it. Thank you for watching.